just speaker on, switch on that button. वो बटन ऑन कर दो बस. Right. Okay, so guys, let's start. So last class I discussed about interfaces concept, and a quick recap is, in an interface you can develop only abstract or incomplete methods. So the other name for incomplete is abstract. Fine. As per Java 7 I'm talking about. Now in Java 8 things were changed, which we will see in our further lectures. But as per Java 7, only incomplete, okay, abstract methods were basically allowed. Now, second thing is, in an interface, we define what needs to be done, and we're not defining how it needs to be done. The implementation is missing because the method body is missing. There is no method body. So we cannot write any code inside the method, which means method implementation details are missing. So where are we going to implement this? In a class. So this interface acts like a contract on the class, and whichever class implements an interface, all the methods of interface should be developed inside that class. Fine. So we took some examples on that. I gave you some clarity with the help of few examples. But today we are going to continue further, and we will start understanding this in a more detailed manner. So let's go here. Press Ctrl F, interfaces. Okay, interfaces in Java. So let's now look at the next point. All variables in an interface by default are final and static. Now what do you mean by this is, guys, in an interface non-static variables are not allowed. Keep this in mind. Okay, non-static variables are not allowed. Whatever variable you create here, these variables in an interface are always final and static. If I now right click here, go to new, and I'll select here interface A. Now after selecting this interface A, whatever variable I create here is static and final. Suppose if I write int max. Now you see, by default, if final variable is not initialized, it will give an error. Is it giving an error? Now what that error is called as? When do we get blank filled error? When the final variables are not initialized, we get blank filled error. So you need not write static and final. By default, they are static and final. If you want, you can still do this. There is no harm in that. Whether you write this or not, variables created here are final and static. Okay. Same way, if I now write here int min, then that's the maximum speed and minimum speed of the vehicle. So here if you don't write final and static as well, still it is final and static. So that is the meaning here. Observe, all variables in an interface by default are final and static. So if I now want to access these variables, I'll do one thing. Firstly, save the file. I'll right click on P1, go to new, create a class B. Now since it is static, we need not create object. I can directly use interface name a dot max, and see that works. SYSO a dot min. Do you see any error here? No, we got the output. Did you understand now? Since it is static, you can use interface name and access this. Okay. Next point. Okay, now read this once again from the beginning, so that the more revision we keep doing it, we'll understand the points clearly. Is this clear? Read this first point. Okay. Next. 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 Does this make sense? Everyone, next, observe the next point is whenever you create an object, inside object incomplete methods are never allowed. Object can have only complete methods and non-static members. Method has to be complete. An object cannot have incomplete method. Now interface has incomplete methods. Yes or no? Now since it is incomplete, an object of interface is not allowed. Understand the reason? Why object is not allowed? Because incomplete methods cannot go to an object. Object will have only complete methods. So an interface has incomplete methods and object creation is not allowed. However, reference variable of interface you can still create. There is no error on that. You don't see any error here. Error is seen while creating object. This is clear? Observe here now. Read this. Is this part clear? All of you? Okay. Now let's proceed further, and I'm going to talk about this part bit later. It forces all the implementation classes to have same method name, resulting in good design. Okay, let's take that example now. We should be able to understand this. So let's say I'm creating one interface called as calculator. Press Ctrl 1 and rename. Now this interface has a method public void add with two numbers int x comma int y. Okay, there are two arguments x and y. Now this add method can add integer values, and it should also be able to add, let's say, square of numbers. There are two things I want to do here. What are the two things I want to do here? Adding integer numbers and adding square of numbers. Now this method should be implemented in two ways. One, it is add integer values. Second, square of number. If I give 10 and 20, then 10 square is 100, 20 square is 400, 500. And if I give 10 and 20, it should add it and give me 30. Two different kinds of addition. So the first calculator will be an ordinary calculator. Let me call this as a ordinary calculator which implements calculator interface. I'll press Ctrl 1 and implement this method. Press Ctrl D to delete the line and print x plus y. Direct addition. Okay. Now see, what is this interface doing? It's forcing this class to have this method name. That is what it is doing. You cannot write a different method name here now. An interface is forcing this class to have method name as add. Now I'll develop another class. Right click, new, create a class called as scientific calculator. Okay. Now observe. This scientific calculator also implements calculator class interface. So this interface is forcing this class also to have one add method, but this add method can add x into x plus y into y. Are you understanding? Yeah? Observe now. In this case, what are you seeing here is this interface is forcing both the classes to have same method name, but inside that method the logic is different, but the method names are same. Now what is the advantage of it? The advantage is now when I create another class, let's call this as class A, where I want to perform addition. What do I want to perform here? Addition. So I'm going to create a main method and I'll write ordinary calculator O is equal to new ordinary calculator O dot add. and I'll give you a 10 and 20. Now you notice the method name is add, but ordinary calculator add method is going to add and give me the output as 30. But suppose if I change this to scientific calculator and same add method, if I'm using it now, it will give me what? Now see, what actually happened because of interfaces, this interface is forcing all the classes implementing it to have same method name. Okay, how did we force all the classes to have same method name? Using an interface. So this interface, when it forces all the class to have same method name, for me it is one method name which can perform two different tasks. Remembering the method name becomes easy. I need not remember separate method names. One method add in scientific calculator, ordinary calculator add performs addition, but the addition here is different. Now this has resulted into a good design. Okay, now why I'm telling good design is because if I remove interface, people would have given a different method name, different method name. Now you need to remember the method names separately. Instead of remembering one method name, you need to remember. Now here only two methods are there. Okay sir, we will remember. But imagine this class has 20 methods. This class has 20 methods. Now in this case, if the method names are different, you have to remember 40 methods names together. Is it now easy or difficult? But if I'm using an interface, then I will force both the class to have same method names. However, logic in that is different. But how many method names I need to remember now? 20. Isn't it? So somewhere we tell it forces all implementation classes to have same method name, resulting in good design. Did you understand this now? Everyone, did you understand this now? Yes or no? Yes, online students, did you understand this part? Please tell me. Are you all clear with this particular thing? If yes, then we can proceed further. We can proceed further. Okay? Yes. Now observe here. Now what is the advantage of the interface? The first advantage is abstraction. What is abstraction is hiding of implementation details of a method. Are you understanding now? What logic is present in the method that has been hidden, and that is what is the definition of abstraction. Meaning, what is abstraction? They'll ask in interview. Hiding of implementation details. That is, we define what needs to be developed and not how it needs to be developed. What needs to be developed and not how it needs to be developed. Are you understanding the definition? What is the definition for abstraction? Read this loudly once. Right? Okay. Now, let us proceed further. Observe. The next one. Read this. We have already seen this now. Next. How the interface forces all the classes implementing it to have same method name. Next. I don't know what is loosely coupled. Wait. We will discuss about this later. Now, all variables by default in interface are, just keep this note in mind. Okay, which we have already covered here. Now we will take more examples on interface. Firstly, look at this note. Whenever you do inheritance class to class, which keyword will you use? Class to class we will use, interface to interface we will use, and inheritance interface to class. So there are three types of inheritance we can do here. Class to class, interface to interface, interface to, let's see this here now. The first example that I'm going to take here is now, I'll create here A, which is going to be one interface. Now I'll inherit the members of interface A to B. Now B here is also what? An interface. And then I'll inherit that to what? C. Now C is going to be class. So this is interface. And this one is also what? Interface. This one is also interface. Now when you inherit from A to B, interface to interface, we will use the word extends. And whenever you inherit from interface to class, you will use the word implements. You will use the word what? Implements. Did you understand this now? Let's try to implement this now. So first I'll create an interface A. Let's go back here. I'll create this interface A, rename, and hold on. Okay, let's do one thing. It will become a lot of work. Instead, we'll delete and create. That will become easy. Just delete all and let's do it like this. Right click, go to new, create one interface A. Now this interface A, I'm going to build one method and that method will be called as test1. So public void test1. We'll create here another interface called as B, and this has a method public void test2, and I'll create here a class C. Okay, now observe. So what are we going to do here now is this. From interface to interface, when you inherit, I will use which keyword? Extends. We don't see any error here, correct? So how many incomplete methods are present in B? Two incomplete methods. Test1, comma, test2. Inherited is 1. From A to B, 1 is inherited. But the total number of methods are what? Now, when I implement B on C, how many incomplete methods are inherited to C? 2. How many are inherited? 2. Now when you press Ctrl 1 and add unimplemented method, what do you see here? You see here, basically we have here how many methods? So let's write SYSO1 and let's write here SYSO2. Now let's write CC1 is equal to new C and then C1 dot test1, C1 dot test2. Did you understand this program? Everyone observe the output, analyze the program once. All clear with this example? Yes. Analyze the program once. Okay. Now let us proceed further. Let's see the next example. Now the next example is all about multiple inheritance on interface can be done. But sir, will it not cause us diamond problem? Let's understand that here. So A here is an interface. Okay. Let's understand here now that what is A here? A here happens to be what? An interface. I'll inherit from A to B. B also here is what? An interface. Is it multiple or multi-level? Multi-level, because the child has only one parent. I'll inherit now from B to C. This is also an interface. Multiple or multi-level? multi-level. Now when I inherit from B and C to D, then this is multiple here. Now understand, let's assume there is one method present in, okay, interface A called as test. Now this method test, you're inheriting from A to B, but this method is incomplete method. There is no logic in it. Logic is not present. You're just inheriting this test method from A to B. Correct? And now same test method you're inheriting from A to C. It's incomplete. Now same incomplete method you are inheriting to D, and from here also incomplete method is going to D. When method itself is incomplete, when method itself does not have logic, why are you thinking about diamond problem? Diamond problem will arise when the method logic which is being inherited, there is a collision. Okay, we are overriding that. But here method does not have the logic at all. So when the method does not have the logic at all, diamond problem cannot arise, though there is an ambiguity from where the method is inherited. Whether it is from A to B, B to D, A to C, C to D, though there is an ambiguity, the method is incomplete. So there is no question of ambiguity which logic is being implemented in D. Now this D can be an interface or a class. That doesn't matter. Can be an interface or what? A class. That does not matter. Let's see this here with an example. Now see A and B, let's delete it. Right? Let's delete this all. Now A and B, I will now write implements A comma B. Firstly, let's take a class. Now you add unimplemented methods, there is no error. Are you understanding what am I telling you? There is no ambiguity here now. Okay? So multiple inheritance I am able to do it. Though C is a class. There is no problem as long as these are interfaces. Now if you complete this class, let's print here 2. Let's print here 1. Let's write main method C1 is equal to new C1 dot test1 C1 dot test2. And now when you right click and do a run as Java application, observe what we see here, 1 and 2. What do we see here is 1 and 2. Observe. Everyone, are you clear with this part? Please tell me. Any questions? Do you have it here? No. So now, this is what the first example we are seeing here, where this one is a class. Now, even if you make this as an interface, then here you cannot use implement. You'll have to use here. Do you see any error? How many methods are inherited to C? From A test 1, from B test 2. How many methods? 2 methods. Did you all get this part? Everyone, see this example 1. Did you understand this example? Everyone clear with this part? Able to follow? Okay. Now see, if you do multiple inheritance of class, then its parent should be, see, interface A, interface B. I'm implementing that on a class. If its parents are interfaces, then multiple inheritance on a class or interface both is allowed. Okay, which we have completed it. So okay, now what do you say? Do you want to take a break here? For today, is this enough? Yeah. Don't look at the timing. There's no point looking at the time of the class. because you already 16th class 3000 lines of notes is already covered. We are nowhere compromising with the content coverage right now. Since it is zero writing, it will become little heavy because you have to go back and practice again. So go back, practice everything. I'll continue with interfaces again tomorrow. Is this clear? Everyone? Okay, see you then tomorrow. We'll discuss tomorrow.